Okay, so previously what we worked with was direct proportion. Okay, the other type of proportion that I have is inverse proportion. Okay, inverse proportion describes a relationship where if one increase or the increase of one variable will lead to the drop or decrease in the other variable. Okay, so the only difference for inversely proportionate, so if y is inversely proportional to x, instead of writing y equals to kx, now is y equals to k over x. Okay, same thing where k is a constant and cannot equal to 0. Okay, so key point here, to show that two variables are in direct slash inverse proportion, all you need to do is to show that k is the same for all pair of values. Okay, what do I mean by this? Okay, later when we work out or we go through an example, okay, you'll be clearer about what is this point about. Okay, so over here is the representation in a graph, okay, how your inverse proportion looks like. So y equals to k over x graph. Okay, so in this case, as y decreases, okay, so when one decrease, okay, since it's inversely proportional, the other should increase. Okay, so y equals to half and y equals to 1 over 10 over here. Okay, if you were to sub it into the value, you will have differing values of x. Okay, so if you look at the example here, the steps that you follow are exactly the same as per what you would do for direct proportion. The only part that is a bit different is when you first form your equation. So inversely proportionate, okay, I start with y equals to k over x because y is inversely proportional to x. Okay, then from there the steps are the same. Okay, same thing in the notes, add in for me where k is a constant. Okay, after I form my equation, proportion equation, I use the information given to find k. After I found k, okay, which is 50, throw it back into the equation that we formed earlier, and then find one of the unknown given the value of the other unknown. That's it. Okay, so if you realize it's exactly the same as direct proportion. Okay, just that when you first form the equation, instead of multiplication or kx, you get k over x for this question. Okay, same thing here. Okay, same thing, read the question carefully. Okay, whether they're talking about the square of x or cube root of x. Okay, in this question it is given that the cube of x is inversely proportional to y. Okay, y equals to b and x equals to a. Find an expression in terms of a for x when y equals to b. Okay, so the first term that they always put in front of the sentence, you always put that as the left hand side term. So this is x cubed inversely proportional to y. So now instead of y being on the left hand side is x cubed. Okay, so x cubed equals to k over y. Okay, form your equation. So use your information, same thing, to find k. So when y equals to b and x equals to a, alright, so when x equals to a, y equals to b over here. Okay, so always write this statement, please. Okay, sub it in, you solve k as a cube b. Okay, so sometimes you are not given exact numerical values. Could be in terms of other constants where they represent in terms of other letters. Okay, so you're asked to find an expression in terms of a for x when y equals to b. So now that I have k, okay, I have the equation of x cubed equals to a cubed b over y. Okay, so I throw in the value of y equals to b. Okay, the b will cancel out where x cubed equals to a cubed. So x equals to a, that is it. Okay, so the steps are the same thing again. Form equation, find unknown k. Okay, then use the equation that I formed earlier to find one of the unknowns given the value of the other unknown. Exactly the same. Okay. This next example here, so this is the example of the point earlier that I mentioned. Okay, how do I prove that something is in direct or inverse proportion? Okay, so you are given that a train travels uniformly from station A to station B. Okay, you have the speed, you have the time taken. Okay, so respective set of values for speed and time. Show that V is inversely proportional to T. So if V is inversely proportional to T, if I write your proportion equation is V equals to K over T. Okay? And if I want to solve for K, okay, so the key thing for this, what you need to prove is prove that K is constant for all set of values. Which means each of these individual set. So if you work out the equation K equals to Vt, right? So if I work out what is the individual value for the different pairs of values that are given to me for V and T. Okay, 100 times cos K equals to Vt, right? So 100 times 1, 50 times 2, so and so forth. They all add up to 100. So my statement will be, since K equals to 100 is constant, okay, V and T are inversely proportional. Then since this is a show question, I'll add the word show. Okay, so the only or the key point of this type of questions is you need to prove that K is constant for all set of values. Okay, which is what they have in this final statement here. Okay, part B, they just ask you to write down an equation. Okay, there's an additional D. It's just write down an equation connecting V and D. Okay, so since I work out K earlier to be 100, okay, V equals to 100 over T. That's it. Okay, then part C is quite straightforward as well. Okay, using the equation form, find the time taken for the journey if the speed of the train is 80 kilometers per hour, which means now if V equals to 80, find T. Okay, so sub back V equals to 80 back into the equation I formed in part B. Okay, and solve for T to be 1.25. Okay, typo as well. Because this speed is in kilometers per hour, this one should be hours, not second. Okay, can. So that is for your inverse proportion in word problems.